Forces problems involving pulleys on an incline. Two particles P and Q of mass 5 kg and 10 kg respectively are connected by a light inextensible string. The string passes over a small smooth pulley which is fixed at the top of a rough inclined plane. P rests on the inclined plane and Q hangs on the edge of the plane with the string vertical and taut. The plane is inclined to the horizontal at angle theta, where tan theta is equal to 0.75 as shown in the diagram. The coefficient of friction between P and the plane is 0.2. The string is released from rest. Find the acceleration of the string and find the tension in the string. So, the first thing to do is to remember that in an exam you're probably going to be given a rough idea of what this diagram looks like. So we have got a rough idea here, but there's a lot of information on that diagram that is missing. For example, we're told that the pulley is smooth, which means there is no friction around the pulley. We're also told that P is on a rough plane, which means we have got to include friction there. We're also told there is a light inextensible string, which means the acceleration is going to be the same through both bits, and that the tension is going to be the same throughout all of the string. Now, the first step we need to do on this is to draw a nice clear diagram highlighting all the key facts. Now this needs to be a pretty big diagram to make it clear what everything is and where everything lies on this shape. So firstly, we've got our incline, okay, and we've got our pulley on the end, and we've got our 5 kilograms, and we've got our 10 kilograms, and that is connected by a string, and it's at an angle of theta. Right, next thing, both these two particles have mass 5 kilograms and 10 kilograms, so we need to find the weight, which remember always act directly downwards. So this one is 5g and for this one is 10g. Also, as we're looking at particle P and Q, P, remember, is on a plane. So the plane must be given a normal reaction to the particle. And remember, it's always perpendicular to the plane. So the normal reaction is off in this direction. If we just carry on looking at the forces on P, we're also, it says it's released, so as Q is released, it's going to fall downwards, which means that P is going to move upwards towards the pulley. And obviously opposing that motion is going to be the friction. So it's going to have a friction acting in the opposite direction, which will be friction max as it's going to be moving. We'll also know that there's a tension in the string there, 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 and there, and in all places that is the same. So we've almost got all the information we need on the diagram. But remember, when we're resolving forces, we resolve forces perpendicular to each other. So what we're going to look at, if we're going to look around P, we're going to look at the forces acting up the plane and perpendicular to the plane. So this weight 5g, we need to find the component of the force that is acting parallel to the plane and perpendicular to the plane. Right, to do that we need to find out this part and this part. So we're told that the angle is equal to tan theta is equal to 0.75. Now my suggestion is that they won't pick silly numbers in the exam. Is to then pick up your calculator and rather than find out what theta is, find out what cos theta is equal to and what sine theta is equal to. To do that, you do tan to the minus 1 of 0.75 and then either cosine that or sine that. And if you do that, you'll find that cosine theta is equal to 0.8 and that sine theta is equal to 0.6. So, now we can complete our diagram. So remember, this bit here is the theta. So, the part here is going to be the sine, so it's going to be 5g times 0.6, and this part here is going to be 5g times cos theta, which is 0.8. One more of a piece of information we're told that the coefficient of friction is equal to 0.2. We're asking the question to find out what the acceleration is and what the tension is. So remember, the acceleration is going to be the same throughout the whole system here. So the acceleration is going to be in that direction. So first thing we need to do is we need to find out what the friction max is going to be. Which, to do this, we have to find out what the resultant is, because remember that friction max is equal to the coefficient of friction times the normal reaction. So we're going to find the forces acting just on particle P in that direction, so acting perpendicular to the plane. So R minus the 5g times 0.8 equals 0, because there's no acceleration in that direction. So if you do that, you'll find that R is equal to 5g times 0.8, which is the same as 4g. So to calculate friction max, we're going to use the equation I've just identified and times it by the coefficient of friction, which we were told was 0.2. So friction max is going to be equal to 4g times 0.2, which is 0.8g, or equal to 7.84 newtons. Right, now we've done that, we can now go ahead and try and find the acceleration. Now to do this, it's going to involve us finding the forces acting up the plane, and what you're going to find when you do that is you're going to have two unknowns. You're going to have the acceleration and the tension unknown, so we're also going to have to look at the forces around Q. But let's start off with carrying on with P. So P, if we carry on with P, we're now going to look at forces up the plane. So up the plane, we've got the T, and acting against it is the friction we just found, which was 7.84, and also we mustn't forget to add on, there is also the component of the weight acting down as well. So 5g times 0.6. And that's equal to 5 times the acceleration. So tidy that up a little bit and you'll get that T minus 3.8 G is equal to 5A. That's by just changing that back into its 0.8 G. Now, as you'll notice, we've got two unknowns in this equation, so we can't solve it. So what we have to do now is we're going to find the forces around Q just acting upwards, because there's going to be nothing acting in that direction. Okay, so we're just going to look at the forces acting upwards. So, looking at Q now, Q, the forces acting upwards is going to be T minus the 10G minus the 10G, and that's going to be equal to the mass, which is 10 times by the acceleration. Now remember, this is going to be accelerating downwards and we're taking forces upwards, so it's going to be minus A. So it's going to be minus 10A. Right, now if we rearrange this equation here to make T the subject, Then we can substitute it into this equation here. So we just rearrange this. We get t is equal to minus 10a plus 10g. And if we sub that into number 1 here, then we're going to be able to find out what the acceleration is. So sub t equals minus 10a plus 10g into number 1. So you get minus 10a plus 10g minus 3.8g is equal to 5a. So collect together the g's on one side, because remember g is just gravity, and the a's on the other, and you end up with 6.2g equals 15a, which means if you sort that out, you find that acceleration is equal to 4.05 ms to the minus 2, or to two significant figures, 4.1 ms to the minus 2. Finally, that's part A completed. We now got to do part B, and in part B we're asked to find out what the tension is in the string. Now, as I said, the tension is the same in all parts of string, so all we have to do here, well, we know what the acceleration is now, so we can just sub our acceleration into one of our equations, probably that one best. So let's substitute sub A equals 4. Substitute A equals 4.05 into minus 10a plus 10g. Okay, so t equals minus 10 times 4.05 plus 10g. Tidy this up and you get t equals minus 40.5 plus 98, which gives you t equals 57.5 newtons, or 58 newtons, to two significant figures. Now here you could use the more accurate answer, which is to do 6.2 times 9.8 divided by 15. There's a lot of work in this question, but everybody should be able to find some parts of it by initially setting up your diagram and finding the components of the forces acting upwards perpendicular to the slope to find out what the friction max is. This question is probably going to be worth in the region of around 10 marks.